In this part 5 video of binary classification machine learning project in bank marketing dataset using Kaggle, here we will dive into the outlier checks, data pre-processing for the machine learning model, and then we will perform trend test split, and we will quickly look at the model evaluation as well before we begin the model training process. Let's straight dive into that. We will utilize the IQR method to find out the outlier, where we will find out the Q1, which is 25th percentile, Q3, the 75th percentile, and IQR is going to be Q3 minus Q1, then lower bound Q1 minus 1.5 times IQR, upper bound is going to be Q3 plus 1.5 times IQR. So we will do that by defining the function that calculates all of those values here, Q1, Q3, IQR, lower bound and upper bound. Here the quantile method or quantile function will give us the Q1 if we use that for the 25th percentile, Q3 if we do that for 75th percentile. So, and then we'll find out the outliers in the data, that is anything less than the lower bound and more than the upper bound is going to be considered as an outlier in the data set. So then we'll count the outlier values, then calculate the percentage of it. Then we will return the outlier count, percentage, lower bound, and upper bound. Here we will store that result in the empty list, and I will go through all the individual numerical columns by calling the function that we have defined. So count and then percentage, lower and upper, and we'll go through in the data frame for each numerical columns here, numerical calls. So then we will append all of those values into the empty list that we have initialized. If we run the for loop on our data set, then we can get a nicely designed data frame of all of those outlier values on the numerical columns. So let me run the column and see what we are seeing in those outlier values. Now here we have got all the outlier values on our dataset and the range, lower bound, upper bound. So in this case study, we may not necessarily remove the outliers because this is the bank marketing dataset. Extreme values are really important when it comes to the large transaction or extremely small transaction, finding out anomalies and making predictions based on that. So we have detected outlier values, which is significant amount of outlier values we have in our data set, which is 18% in P days, and we have a previous 18.26% balance, duration, and so on. And they mostly do not have much of the outlier. This gives us the clear picture of how much outlier we can expect in our data set, but not necessarily we are removing those outlier values. So tree-based models such as random forest are very less sensitive to the even outliers that we have in the dataset. Next, quickly we will look at a couple of feature engineering, and this dataset itself has good amount of column. However, adding some important features might be really valuable too. So we'll create the copy of the data just to be safe. In case we just mess up somewhere and we do something wrong, we can come back here and then reset our data. Then here in the model DF, in the target, we will map our target column value from yes to number 1, no to number 0. We will also map the categorical values of P days with a -1, 0, and 1, where -1 refers to the customer was not previously contacted. Here, feature 2, balance sign. If the customer's balance was greater than or equal to 0, then we'll say non-negative balance, else we'll call negative balance. And the last feature is campaign intensity group. We'll create low, medium, high based on how intensely the campaign was performed. So these are the couple of features we are creating. Not a lot of feature engineering happening here, some sort of mapping, and then we are converting or creating some additional possibly helpful columns in order to make the model even more powerful and feed more information to the models. So as we run these feature engineering, we have some additional columns created here. So for example, here we have balance status, non-negative and negative, campaign intensity being low and high, etc. And then we have the feature 0 here, means that no, customer have not subscribed to the term deposit. And if it was 1 here, somewhere we could have seen that to be 1 in this case. So the final step of preparing the data is creating X and Y input features and target variable. If you exclude the target variable and using drop function, that's going to be our input features or training features, and then Y simply the target variable, which is the target feature that we have just transformed using the mapping function, yes being 1, no being 0. So this way we have created X and Y. Now it is time to map the numerical features and categorical features based on their data type, integer and float, that is numerical features, and object and category, these are categorical features. So after we execute them, we can easily find out that these are our numerical features, these are our categorical features, which is 11 columns of categorical features, 7 columns of numerical features. Now on our labels, 88.3% we have label 0, which is customers have not subscribed for the term deposit, and 11.7% is label 1, which customers have subscribed for the term deposit. Now the train test split comes into the picture. So what we want to do here is we want to split the data into the training set and the test set. Here we will call the train test split function, which we have imported earlier while importing all necessary modules and libraries. There we'll call xtrain and ytrain, the training features and training target, xtest, testing features, and test target. So we'll split that data into 20% being the test size and 80% of those being training size. And then we'll set up the random state to stabilize the randomness, and stratify equals y will help us with the imbalanced data set. As we know that our target is highly imbalanced. In that case, we want to ensure that all the label 0 and label 1 are equally distributed among the training data and the test data. So we want to specify the stratify equals y, stratify equals the target variable. Then we want to print all of those results that we have, including shape of the data, shape of the values, so that we want to ensure that they are equally or distributed in the same ratio. So running that, we have prepared the xtrain, xtest, ytrain, ytest. So as you can see here on the y training, we have 88.3% to be the label 0 and 11.7% to be label 1. Same way for the testing set as well, 88.3% being the label 0, and then here 11.7% being label 1. So we have the equal distribution of the label values on xtrain and ytrain both. Now building a pre-processing pipeline. So we want to fill out missing values. We perform the one-hot encoding for the categorical features. And we want to also scale the numerical features if they are not scaled well and they are almost very large value in some of the columns and very small value in some of the columns. For the numerical features, we want to fill the missing value with the median, and we want to scale the data using standard scaler. And here for the categorical column, we want to fill the missing value with the most frequently repeating value in the column, and here we will perform the one-hot encoding that converts ones and zeros instead of the categorical features. I have a separate video on one-hot encoding and filling out missing value section. Please do not forget to check my YouTube channel for those specifically dedicated session for data cleaning, data pre-processing specifically. Once we define those numerical transformer and categorical transformer, we'll then put that into the preprocessor, which we can apply later when we are training the machine learning models whenever appropriate. So we will call preprocessor, and then we'll call column transformer, and we'll call the transformers, and here we will apply the numerical transformer, and for the categorical data we'll apply for the categorical transformer. Once we have set up the preprocessor, these will be applied when we train the model and we want to have the data nicely formatted. Now, after we prepare those, we want to simply say preprocessing pipeline is successfully created. At the next video, we will create the reusable evaluation function, which will help us to evaluate the model's performance across different model using accuracy, precision, recall, F1 score, ROC, AUC, confusion matrix, and classification report. I'll cover that in the part 6 video. And until then, if you have not already subscribed my YouTube channel, please subscribe subscribe and check out those previous video until part 4, and that was really helpful to understand how does the end-to-end pipeline look like if you're developing a binary classification machine learning model. There are other videos on many different topics as well. Please do not forget to check those, and thank you for watching this video until the last. I'll see you in the next video, part 6. Then we'll begin training each individual machine learning models and evaluate and then predict from using those models.